The next part after our discussion on division by zero is what's called the division algorithm. And so it's the idea that what we do to actually do division, but it really is going to discuss the idea of why we're allowed to do it. And so I'm highlighting some important parts here of the division algorithm, which says if you have two whole numbers, A and B, think of any two numbers, then there exist an unique whole numbers Q and R such this is true. And so in this case is think of any two numbers, and then we can write an equation with those two numbers with there exist two other numbers that would make this equation true for any A and B. And so in this case, this is the division algorithm. It doesn't look like it, but in this case with those letters that we have here, I'll rewrite it here so you can see it. What we have here is some number is equal. For any number, you can go ahead and write an equation like that. Given any two A's and B's, you can find other two numbers that make this true. In this case, B would be called the divisor, Q is called the quotient, and R would be called the remainder. And so to look at what this looks like in practice here, let's take 57 divided by 9. 57 divided by 9, here's our situation. Those are two numbers, A and B. We can take any of those numbers and we can write it in this division algorithm form. And the way we do it is, how many times does 9 go into 57? 6, remainder 3. And so then you have this, right? 9 is the divisor, 6 is the quotient. How many times it goes in? 3 is the remainder. So then 57 is equal to that. And so looking at some alternative examples, let's take a look. What does this mean for, in this case, if A is equal to 44 and B is equal to 13? And again, I'm referencing this idea up here. How do I rewrite that? Well, I'm going to ask myself, how many times does 44 go into 13? It goes 3 times. 39 remainder, that's 5. And so now we can rewrite this here. We can say that 44 is equal to the quotient 3. Sorry, let's go 13 times 3 plus 5. And so you can rewrite any number in this form because of this, what's called division algorithm. If you look at the next one here, again, look at this next one, 96 divided by 8. Try that one there. If you want to try it before I do, go ahead and try it. But we're going to say is 96, 8 goes into that 10, 11, 12 times. That would be 96, remainder 0. And so then we can say 96 is equal to 96 is equal to 8 times 8 times the, what do we got here? 8 times the quotient, which is 12, plus the remainder 0. And so now we have that. So that's an example of what we call the division algorithm, which we're going to end up doing that later, but it allows us to write numbers this way when we're thinking about division. It's a combination of the factors plus the remainder to build any number there. And the last piece is just to think of division as repeated subtraction. So if multiplication is repeated addition, then division is repeated subtraction. So another way you can do 44 divided by 13, like we did over here, is essentially just keep subtracting, subtract. How many times do you subtract? 3. What's the remainder? 5. And so that's what we have there. If we're going to do an example again, we're going to subtract B successfully from A. So you have 22 divided by 6, and so what we do is we keep subtracting 6. There's your 16, there's your 10, there's your 4. I can't subtract anymore. How many times did I subtract? 3. What's the remainder? 4. And so using it as repeated division, I now know that 22 is going to be equal to Again, I can follow that division algorithm here. 22 is going to be equal to 6 times 3 plus the remainder 4. And again, this was using because we subtracted 3 times. And so that's where you end up with division as repeated subtraction.